Question says that for the circuit shown, determine the value of voltage V1 and V2. V1 and V2. If the supply frequency is 4 kilohertz, meaning F is given to be 4 kilohertz, right? Now, that's question 1. Then question 2 says that determine also the value of the supply voltage, meaning V. This is the supply voltage, right? Determine also the value of the supply voltage. Then lastly, we are asked to determine the phase angle. Determine the circuit phase angle. Determine the circuit phase angle and draw the Phasor diagram. Determine the circuit phase angle and draw the Phasor diagram. Now, what are we asked to calculate? V1, V2, the circuit phase angle. Then the next one is what? Phasor. Draw the Phasor diagram. Draw the Phasor diagram. Now, I mentioned this when we started the class. We have Phasor diagram, we have phase angle, and we have the circuit diagram. So we are given the circuit diagram. We have to calculate the phase. We have to find the phase angle and what? Draw the Phasor diagram. Now, this is where the idea comes in. You know, we have inductor. We have what else? We have inductor and what? Capacitor. You know, we said for inductor, what's lagging and what's leading? Is it voltage that is leading? For inductor, voltage leads, meaning current lags. For capacitor, voltage lags, current leads. Now, meaning this is where the idea comes in. By the time you get your value of this phase angle, you now write, is it lagging or is it leading? Is it lagging or is it leading? Now, solution. Understand your circuit diagram. We are given this circuit diagram. In this circuit diagram, it is clear enough to see the relationship between each parameters, right? Now, from here, you are given this circuit diagram. You are told that the current flowing through this circuit diagram, this is it, right? This is the supply voltage. You have to calculate it. And you have to calculate the voltage flowing through this circuit element. Now, this circuit, what type of circuit is it? Is it RC circuit or RL circuit? This is RC circuit. This is resistor and this is capacitor, right? What about this one? RL circuit. This is resistor and this is what? Inductor. Now, meaning Z1 is representing RC circuit and Z2 is representing what? RL circuit. Now, let's write the impedance of both circuits. Now, for Z1, what will be the formula for the impedance? R minus what? JXC. For Z2, what will be the formula for the impedance? R plus JXL, right? Now, what are we asked to calculate? V1. Recall from Ohm's law. From Ohm's law, V is equals to IR. Call this equation 1. Then equation 1 can be written as V is equals to what? IZ. Call this equation 2. Now, from equation 2, you can use equation 2 to get V1, right? You can use equation 2 to also get what? V2. And if you remember, what I said earlier is that to know if you are correct, the summation of V1 and V2 will give you this supply voltage. I said something like that before. That is, to get the first unknown, this is your formula. To get the second unknown, you are using this equation. To get the first unknown, you are using this equation. To get the second unknown, you are using this equation. Now, to get this third unknown, what are you going to use? That will be what? V1 plus V2. Also take note that if the question says that find the total impedance, same idea. Meaning for total impedance, what do you have? Z1 plus Z2. But in this case, the question just says that find the total supply voltage. So you are using equation 3. Then next up, we are asked to find what? What are we asked to find? Phasor diagram. Phase angle. So to find your phase angle, we know that we are still using, everything is from equation 2 here. And from equation 2, we have B is equals to what? IZ. Now, when we explain the idea of phase angle, when we explain lag and lead, we make Z the subject of the formula, right? We make Z the subject of the formula. Then we concluded which one is lagging, which one is leading. Similarly, what you are going to do here, make Z the subject of the formula. Z becomes what? V over I. call this equation 4. Now what this means is that what equation 4 is telling you is that the supply voltage of this circuit diagram and the supply current of this circuit diagram, you substitute. By the time you substitute, you know it varies. By the time you substitute, one will be lagging, one will be leading. Are you know what I'm saying? Let's say at the end, let's say we get something like this. We got something like this. Z is equals to V negative 30 degree over I then 0. What will be your conclusion here? The voltage lags the current by what? The voltage lags. When we say lag, meaning reduce. We end up putting minus again. So meaning the voltage lags the current by what? 30 degree. In other words, the current is leading the voltage by 30 degree. Are you getting me? So let's say by the time you solve equation 4, you got something like this. V then 30 degree over I. What will be your conclusion here? The voltage leads the current by 30 degree, right? In other words, current lags the voltage by 30 degree. So depending on what you will be getting, then you come into conclusion by saying your phase angle, is it lagging or leading? By the time you solve, you are going to know. So these are what we'll be implementing. We will be implementing what? 1, 2, 3, and 4. By the time we implement 1, 2, 3, and 4, you are going to get this or no. Then lastly, we are going to draw this Phasor diagram. The idea of Phasor diagram is that you are using what? Argand diagram. Recall from Argand diagram, you have your Cartesian coordinates, right? This is your imaginary part of Z, and this is your what? Real part of Z. This is your real part of Z. So what it means is that you'll be representing the value of V1. You'll be representing the value of V1, which is the current, which is for RC circuit, right? And this is for what? RS circuit. So you'll be representing the value of V1 and V2, which are RC circuit and RS circuit on this Argand diagram, respective to the angle that you have. Then you have a total current here. And what will be the formula for total current? Is equals to V L, right? Plus, it will be VL plus what? VR. So these are all what we'll be implementing to solve this question. Now let's start. Any questions so far? I just want you to understand the concept. So by the time you understand the concept, you won't find it difficult. So what this means is that
why is it not VL
minus. Okay. Yeah, that's true. VL is actually VC. VL plus VC. So V of your inductor and your capacitor. So that's correct. So meaning that what this means is that you can see the way we analyze this question. We analyze it step by step. So given any complex circuit, your first task is what? Calm down, look at the circuit, understand what you are giving and what you are not giving. What are you calculating? What am I not calculating? Do you understand what I'm saying? Now let's solve. Now, the first one we have to calculate is what? V1. What will be the formula of V1 from what we've explained so far? Please, let's do this together. IZ1. What's our I? I is given to what? 60 degree ampere. Let's get Z1 using the formula of what? Using the formula. Check. What will be the formula? R minus XC. Now, what's our R? R is, check this diagram. What's the R? What's your XC? Unknown. Solve. XC using the formula of what? 1 over 2 pi FC. Now, meaning that XC becomes what? 1 over 2 pi. What's frequency? Frequency is what? 4 kilohertz times 4 times 10 raised to power 3. What's your capacitor? 2.65, 2.65, 2.653 times 10 raised to power negative 6 microfarad. Now, input this in your calculator. What's the answer? 1. This is 1. 2 pi. F frequency kilo 4 times 10 raised to power 3 multiplied by your capacitor microfarad. Microfarad by micro 10 raised to power 6. So input this in your calculator. Tell me the value of SC. What's your SC? S is equals to what? 15 ohms. Approximately 15 ohms. Right? Now, to get Z1, substitute. What's your R? 8 minus J. What's your XC? 15 ohms. And I said that it is always easier if you want to calculate a value of a parameter, let's say voltage or current, expressed in what? Expressed in what? Polar form. Expressed in polar form. Right? Since I is in polar form, it's your choice. It's your choice. You might decide to express in polar form or what? Rectangular form. Now, I is in polar form, Z is in rectangular form. It's left to you. You might decide to express both in rectangular form or polar form. You still get the same answer, but it's always easier if you have it in what? Polar form. Now, let's express this in polar form using the formula R is equals to square root of B squared plus A squared. What's our B? What's our A? Let's do this directly. That becomes what? Negative 15 square plus what? 8 square, right? What's the answer? R is equals to what? 17 ohms. Then theta, which is tan inverse of B over A. Substitute. Tan inverse. What's B? What's A? That's negative 15 over 8. What's the answer? From here, your A is equals to 8 and B is equals to negative 15. Negative 61.9 degree. Therefore, Z1 in polar form becomes what? 17, then negative 61.9 degree. Now, come back to equation. Come back to your equation, which is equation 1. Substitute. Meaning substitute the value of Z that you've gotten in polar form. Let's substitute equation 1. Meaning V1. What's our V1? Your 6, your current 0 degree multiplied by what? 17 negative 61. Now, this means that 6 times 17, right? 0 degree plus all into bracket negative 61.9 degree. Multiply this. What's the answer? This is 102. Then this will give you negative 61.9 degree. So this is the answer. Meaning the voltage across this RC circuit. This is it. Now, the same way we solve this, let's solve V2. Solving V2, this becomes your formula. I multiplied by what? Z2. What's the formula for Z2 in this case? R plus JXL. Let's solve for XL using the same concept, meaning 2 pi FL. Substitute. XL is what? 2 pi times, what's your F? Given 4 times 10 raised to power of 3. What's your L? Given, right? 0.477. 0.477 times 10 raised to power negative 3. Therefore, XL. Substitute this in your calculator. What's the XL? No approximation. 12 ohms, right? 12 ohms. We've gotten XL. We've gotten XL to be 12 ohms. We've gotten XL to be 12 ohms. And what's R? R is what? From this diagram, R is what? R is equals to 5 ohms. Therefore, Z2 becomes what? 5 plus J12 ohms. Right? Using equation 2 that says that V2 is equals to I multiplied by Z2. Now, I is given to be what? 6 at 0 degree. And Z2 is given to be what? 5 plus J12. Up to this level, what are we going to do? Up to this level, I should convert this to polar form. Now, let's convert this to polar form. Identify your A. Your A is what? 5. And your B is what? 12. Now, using your formula, square root of B squared plus A squared. This becomes what? Substitute. Your R is what? 12 squared plus 5 squared. What's the answer? This is what? 13 ohms. Now, let's solve for theta. Theta is equals to tan inverse of B over A. Substitute. Meaning theta is equals to tan inverse. What's your B here? 12. 12 over 5. What's the answer? Theta is equals to what? 67 what? 0.4 degree. That is Z2 in polar form becomes what? Z2 in polar form, that's what? 13, then what? 67.4 degree. Any question? We've gotten, this is the formula to calculate the second question. Now, up to this level, we've solved for R and theta using the same process, right? Then we know that Z, giving Z2 in 5 plus J12, right? Which is in polar form. To convert it to rectangular, this is rectangular form. To convert it to polar form, this is what you just need, right? Any question? And since we've gotten our R, what was our R here? 13 ohms. What was our theta? 67.4 degree. Therefore, my Z becomes what? 13 at what? 13, then 67.4 degree. Implementing equation 2, meaning V2 becomes what? What's your current? 60 degree multiplied by your Z2, 13, 67.4 degree. Now, multiply, meaning 6 times 13, right? Then 0 degree plus 67.4 degree. What's the answer, please? V2 becomes what? 78 at what? 67.4 degree. So this is number 2. You've answered number 1, you've answered number 2. What's number 3? Number 3 means, number 3 is this guy, the total supply voltage. By total supply voltage, meaning V1 plus V2, that becomes what? Substitute. What do you have? What's V1? 102 at what? Minus 61.9 plus what? Plus this answer, 78 at what? 67.4 degree. Now the question is it possible for me to add something like this in complex number? No. Is it possible to add something like this in complex number? No. So you are going to convert you are going to convert V1 to Cartesian form, convert V2 to Cartesian form. Now let's convert. You know why I'm converting V1 and V2, right? Because in complex number it is not possible to add something of this nature. So I'm converting V1 to rectangular form. I'm also converting V2 to what? Rectangular form. Then by formula, converting your polar to rectangular form. This is the formula, right? R cos theta plus J sin theta plus JR sin theta. Now let's convert V1. What's V1 here? 102 at what? Negative 61.9, which is the same time writing 102 cos what? Negative 61.9 plus J 102 sin negative 61.9. True or false? So let's get the value of V1. Similarly, for V2, since I have V2 from here to be what? 78 at what? 67.4 degree, which is still the same time as writing 78 cos 67.4 degree plus J 78 sin 67.4 degree. Now input this in your calculator. What's V2 and what's V1? By the time you input this in your calculator, 102 cos this will give you 48, negative J90. Then this will give you 30 plus J72, right? Now come back to this equation. Now substitute your rectangular form of V1 and V2. That becomes your total voltage supply, meaning VT becomes what? Substitute. Let's do this together. That's what? 48 minus J90 plus what? 30 plus J72. Comparing part and imaginary part. That becomes what? 48 plus 30 plus J all into bracket negative 90 plus 72. This will give you what? 78 minus J18. This is your voltage supply, right? In Cartesian form. Now let's get this in polar form. You know, the question says that calculate the total supply voltage and what? The what? Circuit phase angle. So you can get circuit phase angle using polar form from polar form. You get circuit phase angle from polar form. Now let's convert this to polar form. You know how it works now. R is equals to square root of 78 square plus what? Minus 18 square. And theta in this case is tan inverse of negative 18 over 78. Any question on this? Our A here is what? 78 and our B here is what? Negative 18. Just like what we've been doing since morning. Alright, press this in your calculator. What's the value of R? 80. And what's the value of this? Confirm that for me. What's the value of theta? 12 point what? To get our supply voltage up to this level, we are using this guy, meaning V1 plus V2. But we have our V1 in polar form and our V2 in polar form. But is it possible to add something of this nature when it comes to complex number? No, right? So meaning you have to convert your V1, which is the current flowing through your capacitor, into your Cartesian form. This is it. Similarly, convert your V2, which is your current flowing through your inductor, to Cartesian form. Then by the time you've done that, we added it up, we got this, right? This is our A, this is our B. Meaning this is my V total in Cartesian form and this is my V total in polar form. Now, the next question says that find the phase angle. What's the current phase angle? And draw the Phasor diagram. How it works is that your current phase angle, given any question, your current phase angle depend on your total voltage. Now observe, from here, from the polar form of your total voltage supply, in polar form, we have 80 at negative 13 degree, meaning the angle is what? 13 degree. This is how you go about it. From here, when we explain inductor and capacitor, we said we have two value of voltage, right? The first one, we said it is lagging and it is leading. You recall that when we have the value of voltage being 90 degree, okay, this is it. When we say I, from here, we said Z is equals to V at 90 degree or divided by I at 0 degree. Then we said Z is equals to V at negative 90 degree or divided by I 0 degree. Now for this first one, call this two. For this first one, what's the interpretation? The interpretation is that your voltage is leading. Your voltage is leading, right? If your voltage is leading, what does it mean? Your current is lagging. Now check case 2. For this case 2, what's your interpretation? Your interpretation is that your voltage is lagging, meaning your current is what? Leading. Now apply the same idea up to this level. We got 80 at negative 13 degree. Obviously your voltage in this case, is it leading or lagging? It is lagging. It is lagging. Relate it to case 2, meaning your voltage is lagging. And if your voltage is lagging, that is your current is leading. Now what it means is that when you want to write your answer, say you are solving theory question, when you want to write your answer, you might go with negative 13 degree or 13 degree. You are still correct. Now writing your current phase angle, meaning negative 13 degree, right? Lagging. What's lagging? Voltage. I hear what I'm saying. Now writing your current phase angle 13 degree, meaning leading. What's leading? Current. So the overall idea is that it varies. You might go with negative 13 or you go with 13. You are still saying the same thing. Just state the condition. When you are going with negative 13, it means your voltage is lagging. When you are going with positive 13, it means your current is leading. So in textbook, you are going to see there, they won't write, is it current leading? Is it your current that is leading or voltage that is leading? They won't write it there. They are just going to write leading or lagging. You should know what it means. Alright, the last question says that draw the Phasor diagram. Draw the Phasor diagram. When we started this class, we said we are implementing 3 things, right? The first one is our circuit diagram. The second one is the first one is our circuit diagram. The second one is what? Phasor diagram, and the third one is what? Argand diagram. Now, when drawing your Phasor diagram, you are making use of your Argand diagram. When drawing your Phasor diagram, we are making use of your Argand diagram. Now, we've gotten 3 value of voltage, right? We've gotten 3 value of voltage. The first value of voltage is the voltage flowing through your capacitor. The first value of voltage is the voltage flowing through your capacitor. The second value of voltage is the voltage flowing through your inductor. Then the third value of voltage is the total supply voltage, meaning what we did here, meaning that V1 plus V2. This V1 is for your capacitor, while this is for your inductor. So this is what you'll be using to draw your Phasor diagram. Now, recall, when you have from argand diagram, you have your imaginary part and your real part, right? You have your imaginary part and your real part. Basically, your imaginary part takes the y-axis, then your real part takes the what? X-axis. This is X, this is Y. This is your Y, this is your positive Y, this is your negative Y, this is your positive X. So this is what we'll be using. We want to plot the voltage of capacitor, the voltage of inductor, and the total voltage. Now, your voltage of capacitor and voltage of inductor, they are plotted on the y-axis. They are using their respective angle to plot. To plot this voltage. Now, for this VC, we got 102 at negative 61.9. Then this is the voltage of capacitor, right? And this is the voltage of what? Inductor. Now, how it works is that your voltage of capacitor is taking the negative x-axis. Or let me generalize it. This is how it works. For your inductor, generally, for your voltage of your inductor, takes the positive y-axis. Then your voltage of capacitor or resistor takes the what? Negative axis. Now, take note. Your voltage of capacitor or resistor takes the negative axis. Then your voltage of your inductor takes the what? Positive axis. Take the positive axis. Now from here, this is 90 degree, right? This is also what? 90 degree. This is 90 degree. This is also 90 degree. Now from here, let's plot the first one. For the positive y-axis, I have voltage of inductor. For the negative y-axis, I have the voltage of my what? Capacitor. Now let's plot the first one, which is the voltage of your inductor. What's our answer? That's 78 at 67.4 degree. Now when you are plotting the voltage of your inductor, you are using the angle. If this is 90 degree, your 67.4 degree, where is it going to be? Let's say you have your 67.4 degree. This is 0, 0, 30, 0, 15, 30, 45, 60, 75, then 90. So let's say you have 67.4 degree. Let's say this is your 67.4 degree. 67.4 degree. And what's giving you 67.4 degree? 78. Meaning 78 is giving you, we have 67.4 degree, right? And what's giving you 67.4 degree? 78. So indicate your 78. Next up, we have the voltage of your capacitor. When we solve that, we got 102 at negative 61.9. I said earlier on that your capacitor or resistor is at the what? Negative y-axis. Your capacitor or resistor is at the negative y-axis. Now, if this is 90 degree, 61.9 will be somewhere around here, right? Where will I have my 61.9? I have it. Observe something. If from here to here is 67.4 degree, meaning 61.9 will be closer than this, right? So let's say we have 61.9 degree. What's giving you 61.9 degree? 102, right? 102. Then lastly, let's plot our V total, meaning the total supply voltage. From what we got here, what's the angle? We are having negative 13, right? We are having negative 13. The question is, am I plotting this negative 13 at this at this region of y or this region of y? Is it this region of y? This negative 13. I want to plot it on this my Argand diagram. Am I plotting it at this region of y or this region of y? Let's say this is 1, let's say this is 2. Is it 1 or 2? Down, I'm plotting it at 2. The question is why? I'm plotting it at 2 because we said that our negative angle is taking this side, meaning negative y. Our negative angle is taking the negative side of our y-axis. All right, now I want to plot negative 13. So let's say we have negative 13 somewhere here. If this is 61.9 degree, so you have negative 13, meaning 13 degree. What's giving you 13 degree? 80. 80 is giving you 13 degrees. So indicate. Now from here, your last step is to join these points together, meaning you have something of this nature, and this is your Phasor diagram for your circuit, for the given circuit. This is your Phasor diagram, and this is your Phasor diagram for the given circuit. What if the question says that indicate the value of current? Indicate the value of current using your Phasor diagram. Same idea. What you are just going to do, this same line, meaning that the voltage of your capacitor or the voltage of your resistor. So you have indicate your current value here, meaning you have something like this. And what's the value of current in that circuit? What's the value of current in that circuit? 6
at 0 degree.
6 at 0 degree. 6 at 0 degree. So this is how you plot your Phasor diagram given any circuit question on application of complex number to series AC circuit. So this is how you plot your Phasor diagram.